Hello students, welcome back to my channel. In this video, we will learn an important concept from Unit 1 called scientific notation. So let's understand it in a simple way. Students, in chemistry, we often deal with extremely large and extremely small numbers. Let's look at an example of a very large number. This number represents the approximate number of molecules present in 2 grams of hydrogen gas. You can see that it contains a large number of digits. Imagine performing calculations with numbers like this repeatedly. It becomes difficult to read, write, and calculate. Scientific notation provides a simpler way to express such numbers. Now let's look at a very small number. This represents the mass of a hydrogen atom in grams. Notice the large number of zeros after the decimal point. Such numbers are difficult to handle and can easily lead to errors while writing. So students, scientific notation has 3 major advantages. First, writing large and small numbers become easier. Second, calculations become simpler. And third, numbers are expressed in a compact and convenient form. That is why scientific notation is widely used in chemistry and other branches of science. A number in scientific notation is written in the form capital N into 10 to the power small n, where capital N is a number greater than or equal to 1 but less than 10, and small n is an integer called the exponent. The exponent may be positive or negative depending on the number being represented. Now let's understand this with examples. Consider the number 232.508. To convert it into scientific notation, we move the decimal point to the left until only one non-zero digit remains before the decimal point. So the number becomes 2.32508. The decimal point has been moved 2 places to the left. Therefore, the exponent becomes plus 2. Hence, 232.508 becomes 2.32508 into 10 to the power 2. Remember, when the decimal moves to the left, the exponent is positive. Now consider the number 0.00016. To write it in scientific notation, move the decimal point to the right until only one non-zero digit remains before the decimal point. So the number becomes 1.6. The decimal point has moved 4 places to the right. Therefore, the exponent becomes minus 4. Hence, 0.00016 becomes 1.6 into 10 to the power minus 4. Remember, when the decimal moves to the right, the exponent is negative. So let us revise this rule again. If the decimal point moves to the left, the exponent is positive, and if the decimal point moves to the right, the exponent is negative. Left means positive, right means negative. Now let's test our understanding. Convert the following numbers into scientific notation. First number is 45,000 and second number is 0.00045. Pause the video and try solving them yourself before looking at the answers. Now let's check the answers. For 45,000, the decimal point moves 4 places to the left. Therefore, 45,000 will become 4.5 into 10 to the power 4. For 0.00045, the decimal point moves 4 places to the right. Therefore, 0.00045 will become 4.5 into 10 to the power minus 4. Now let's see multiplication in scientific notation. Students, remember 2 simple steps. First, multiply the coefficients normally. Second, add the exponents. For example, let us see the multiplication of 5.0 into 10 to the power 4 and 2.0 into 10 to the power 2. Now 5 and 2 are coefficients. So if you multiply 5 and 2, this will give 10. Now 10 to the power 4 and 10 to the power 2 is remaining. So simply we will add 4 plus 2, that is 10 into 10 to the power 4 plus 2, that will give 6. Now this 10 into 10 to the power 6 can be written as 1.0 into 10 to the power 7. So multiply the coefficients and add the exponents. Now let's look at division. Again, there are two simple steps. First, divide the coefficients. Second, subtract the exponent of the divisor from the exponent of the dividend. For example, 6.0 into 10 to the power 12 is divided by 2.0 into 10 to the power 8. Now you simply divide 6 by 2. That will give 3. And now subtract the exponents. That is 3 into 10 to the power 12 minus 8, which will give 4. So the answer will be 3.0 into 10 to the power 4. So remember, divide the coefficients and subtract the exponents. Students, addition and subtraction are slightly different. Here we cannot directly add the coefficients unless both numbers have the same exponent. So always check, are the exponents equal? If not, convert one number so that both have the same exponent. Only then add or subtract the coefficients. For example, 6.65 into 10 to the power 4 plus 8.95 into 10 to the power 3. Now here the exponents are different. One is 10 to the power 4, another one is 10 to the power 3. Now here you can convert either 10 to the power 4 into 10 to the power 3, or you can convert 10 to the power 3 into 10 to the power 4. So let us convert 10 to the power 3 into 10 to the power 4. So what will be the result? 8.95 into 10 to the power 3. If we convert it into 10 to the power 4, this will give 0.895 into 10 to the power 4. Now both numbers have the same exponent. Now simply add the coefficients. So coefficients are 6.65 and 0.895. So this will give 7.545. Therefore the answer becomes 7.545 into 10 to the power 4. Now let's see subtraction. 2.5 into 10 to the power minus 2 minus 4.8 into 10 to the power minus 3. Again the exponents are different. One is 10 to the power minus 2 and another one is 10 to the power minus 3. Now you can either convert 10 to the power minus 2 into 10 to the power minus 3, or you can convert 10 to the power minus 3 into 10 to the power minus 2. Now again so let's convert 4.8 into 10 to the power minus 3 into 10 to the power minus 2. So this will become 0.48 into 10 to the power minus 2. Now subtract the coefficients. That is 2.5 minus 0.48. This will give 2.02. So now the answer becomes 2.02 into 10 to the power minus 2. Now let's move to our another topic, significant figures. Every experimental measurement has some uncertainty. Why? Because measuring instruments have limitations and human observations may also introduce small errors. No measurement is perfectly exact. That is why we need the concept of significant figures. Consider the mass of the same object measured using two different balances. A platform balance gives a mass of 9.4 grams. An analytical balance gives 9.4213 grams. The analytical balance provides more detailed information and is therefore more precise. Notice that the last digit is uncertain. This uncertain digit is included in significant figures. What are significant figures? Significant figures are meaningful digits that are known with certainty plus one digit that is uncertain or estimated. For example, 11.2 milliliters. The digits 1 and 1 in 11 are certain. The digit 2 is uncertain. Therefore, this measurement contains 3 significant figures. Now let's learn the rules for counting significant figures. Rule number 1. All non-zero digits are significant. For example, 285 contains 3 significant figures. 0.25 contains 2 significant figures. Every non-zero digit is counted. Rule number 2. Zeros before the first non-zero digit are not significant. For example, in 0.03, there is only one significant figure. And in 0.0052, there is only two significant figures. So these zeros only indicate the position of the decimal point. They are not counted. Rule number 3. Zeros between the two non-zero digits are significant. For example, 2.005. So 2.005 has 4 significant figures. Rule number 4 deals with zeros at the end of a number. If a decimal point is present, the ending zeros are significant. For example, 0.200 has 3 significant figures. 100 point has 3 significant figures. 100.0 has 4 significant figures. However, without a decimal point, ending zeros are generally not significant. So, 100 has 1 significant figure. 1000 has 1 significant figure. Rule number 5. Counting numbers are different. Examples include 2 balls or 20 eggs. These numbers are counted exactly, not measured. Therefore, they have an infinite number of significant figures. Now, an important advantage of scientific notation is that all digits written in the coefficient are significant. For example, 4.01 into 10 to the power 2 contains 3 significant figures. Similarly, 8.256 into 10 to the power minus 3 contains 4 significant figures. So, scientific notation makes significant figures much easier to identify. Students often confuse precision and accuracy. Precision refers to how close repeated measurements are to one another. Accuracy refers to how close a measurement is to the true value. For example, suppose there is a true value which is 2.00 grams. So here is a table given for 3 students A, B and C. 2 measurements are given, measurement 1 and measurement 2, and an average of these measurements is given. Now look at these numbers of measurement 1 and measurement 2 and the average number carefully. Student A's values are close to each other but not close to the true value. So they are precise but not accurate. Student B's values are neither close to each other nor close to the true value. So they are neither precise nor accurate. Student C's values are close to each other and also close to the true value. Therefore, they are both precise and accurate. Now, addition and subtraction of significant figures. When adding or subtracting measurements, the final answer cannot have more decimal places than the least precise measurement. Now look at the numbers given. Here you have to add 3 numbers, 12.11, 18.0 and 1.012. Now 18.0 has only 1 digit after the decimal point. So result is written up to 1 digit after the decimal point. So even if the answer is 31.122, the final answer will be 31.1. Now let's see rounding off. If the digit being removed is greater than 5, increase the previous digit by 1. For example, 1.386 will become 1.39. If the digit being removed is less than 5, keep the previous digit unchanged. For example, 4.334 will become 4.33. Now what happens when the digit to be removed is exactly 5? So look at the digit before 5. If that digit is even, leave it unchanged. For example, 16.345 becomes 16.34. No change is required. But if the previous digit is odd, then increase it by 1. For example, 16.355 becomes 16.36. This rule helps reduce bias in scientific calculations. So today we learned multiplication and division in scientific notations, addition and subtraction in scientific notation, significant figures, precision and accuracy, rules for counting significant figures, addition and subtraction involving significant figures, and rounding of results. These concepts are extremely important because they form the foundation of scientific measurements and calculations. If you found this video helpful, don't forget to subscribe to the channel. Keep learning and stay consistent.